Hello everybody. Today I am going to show you a simulation of solar system in AutoCAD. The program is made using AutoCAD VBA. So let's start. First I will show you the demo of this program. The dialog box pops up. The different options there are. So first I will revolute both the Earth and the Mars around the Sun. I will take these checkboxes and click on run. So these will start rotating. If I want to see the Earth's rotation, I will see the Earth's rotation, right? I will zoom in the Earth. Yes. I will only take this Earth rotation and run. We can change the number of Earth rotations in a day if I want to. By default set to 4. The maximum is 24. Okay. So when the revolution is going on, if I want to see the moon's track, the path of the moon, I can also see. I will set to 4 or else it will get slower. And take this checkbox moon tracking. So you can see the moon's path is being tracked. And if I want to clear the track, I can click on clear track and clear the track. Okay. And these options, moon rotation around the sun and moon rotation around the earth, is given, or else the moon's path will be not correct. I'll show you why. I will click on, I will only take this moon rotation around the earth. You can see how it will work. Where did it go? Okay, we will only take this moon rotation around earth. You will wait a second. You see the moon's path is not correct, right? It's not rotating in its own orbit, not revoluting around the earth in its own orbit. And if I take only this checkbox moon rotation around earth, you will see the moon is going with the earth and it's going at the same speed the earth is going around the sun. So it is wrong, right? It will rotate 12 times around the earth when the full rotation is completed. Revolution is completed of around the sun. It will be correct when I tick this both checkboxes. Now it is correct. Now we will see the code. Wait a minute. Correctly the tracking. Right. I will see the code. Let me maximize it. So yes. First, an object of this FRM solar system simulator is being created, and then it is shown to the user. Then this dialog box pops up, and then the user clicks on the run, and then it's event click of run. This run sim function is called. Here the values of these controls from the user form is passed. If you go to the definition, it takes parameters such as Boolean Earth rotation, Boolean Earth revolution, Boolean mass revolution, Boolean tracking. Boolean moon rotation around it, and number of earth rotations in a day. They are used to simulate the solar system. Then the start time function is called, and this init function is called, and passed these values. These values are passed in it. These actually initializes these values. You can see here in this init function. These are set to be used later. Then a for loop is run from 1 to the number of days in a year, that is 365 days. And what it will do in one day, it is written down in this for loop, right? Yes. So first the sun center will be equal to the sun dot centroid. We have set it. And if this earth rotation checkbox, the value, it if it is true, then it will do this piece of code. So again it will run a for loop from 1 to the number of earth rotation in day. It will, this code explains what it will do. This says to the AutoCAD it will do in 1 hour. H means hour, right? And it also checks if it's need to stop. I will explain it later why we have written this. And if earth rotation is true, it will do this piece of code. In here we have said if earth revolution is also true, then it will rotate the earth axis, the moon and the moon orbit, right? And if Boolean math revolution is also true, then it will also rotate Mars. And if the Boolean moon rotation around Earth is also true, then it will also rotate the moon around the Earth. And we have called rotate 3D to rotate the Earth around its own axis. And then this for loop ends. And if only the Earth revolution is true, then it will rotate the Earth axis and the rotate moon and moon orbit. And this code is same. If it is rotated, if the Boolean moon notation around Earth is true, then we'll rotate it, will call this function, and we will pass these values. And if Boolean mass revolution is also true, then we'll rotate the mass, right? Down here we have created this moon rotate around Earth function, right? So actually what this does is it takes input the degree, how it the number of degrees will rotate around the Earth as input parameter, and then Earth center is set as Earth rotation, Earth dot insertion point, and then rotate function is called, and moon is rotated around the Earth, and how much it will rotate is given by the user. It is passed in actually. And then if tracking is also true, then it will add point where it is in that specific time. That way the track will be seen, right? So now let me explain why we have written this piece of code. Let me run it first. You actually see, let me run. When this simulation is being passed, doing it is going on, you can't do anything here because it is not multi-threaded. This AutoCAD VBA is not multi-threaded. That's why we can't do anything while it is running. It will it will be updated when we have clicked stop, or the what was going on is stopped, right? So to do that, what we have did, I will explain you now. You see, when this runs if function is called, first this start time function is called, right? What this does is it writes one in a text file. Okay, text file, and it is said that if the value is 0, it will stop, and the or sorry, it will set the checkif need to stop as true, and the if it is 1, it will be set false, right? So you'll see that when we click on stop, this code is written in Excel VBA. When we click on stop, this Excel actually writes the 0 in the text file, and when it is checked in AutoCAD VBA, it does the work what it needs to. If it is set to 1, it will the program will go on. At 0, it will stop. I hope you have found it interesting. If any feedbacks, you can leave it down in the comments. Thank you.